Okay, welcome back. So I kind of wanted to give you a feel for something different that you can do with agent sheets, and that is simulations. So this is one of Carla's simulations, and I just wanted to walk you through it so that you could get a feel for some of the more quote scientific things that agent sheets allows. So what we have here is a forest, okay, and the whole idea of the simulation is that you can start a fire someplace in the forest, and you do that by yourself. You simply select a tree and say, "Hi, you're on fire," and then you can watch as the fire spreads to the entire forest and see what happens. So let's slow the simulation quite a bit. We'll run it, and this is how we start a fire. We use the finger tool and just click someplace. Let's see what happens if we set that guy on fire. And as you can see, the fire is spreading a little bit, okay? And it doesn't look like we're going to be able to survive. Yeah, there's a handful of trees are surviving. That's good, okay? But this gives you a feel for what happens. We could do a lot more different things with it. Like, for example, take into account wind and all sorts of stuff. But still, it's pretty good. And for not a lot of effort. I mean, this is something that your students could definitely build. So let's talk about it. Let's start with the tree, and let's see its actions. Okay, so the first thing that I want you to know is look right here at the method names. The tree is not just doing wild running. It has two very distinct methods. The first one is perceive. That's when it looks around and it sees if there's any kind of a fire going on. So if we happen to be a pretty happy tree, okay, there's no fire yet, but we're next to, and this is another condition that's new, we're next to a burning tree, and here we can select just how bad next to means. And what we're saying is that greater than or equal to 1. We can change that. It could be greater than or equal to 2, whatever we want, okay? Well, in that case, there's an 80% chance that we're going to decide to start burning, okay? So burning is just agent property. So yeah, that's what it'll do. Okay. Now this is what act does. In the case that we are currently looking at a healthy tree, but burning happens to be equal to 1, then we're going to change to the burning icon or the burning depiction of the agent. And if we happen to see the burning depiction of the agent, then there's a 50% chance that we're going to change to a dead tree. Okay, we're finished burning. At that point, we update some simulation properties. And this is why simulation properties are so cool, because we can keep track of things like how many trees have burned, what percentage of trees have burned, okay? So that's what we're doing there. And those are things that we can plot over time, for example, okay? Here, when we touch a tree, then it starts burning, okay? And finally, if we tell a tree to delete, it just erases itself. So that's the code for a tree. And you see that the heart of the simulation is actually just this one line that says if we're next to at least one other burning tree, then with an 80% chance, we're going to start burning. You can change this. You can set it, for example, to 30 or 40 or 50. Okay. All right. So let's get rid of that. The background in this particular game is actually interesting because when it gets a message to create a forest, okay, then what it does is with a given percent chance, and that could be 10% chance of building a tree, 20% chance of building a tree, whatever. With a given percentage chance, it'll actually build a tree, and then it keeps track of how many trees it's built. The reason that we need to keep track of that is so that we can get the percentage of burning trees. And finally, we have this guy here in the corner. He's the controller. He's there for a very, very simple reason. It is simply to tell all the trees, hey, look around, see if you spot fire. That's this first message. Tell all the trees, broadcast to all the trees to perceive. Once they do that, it says broadcast to all the trees to take some action, okay? If we didn't do this, if we simply let the trees themselves decide, then it's possible that a tree could completely burn to the ground before the neighboring trees had a chance to feel it. So that's why we want to make it go in lockstep, okay? Now, this particular thing here is when we touch the controller, with the pointed finger, then what it's going to do is it's going to tell all the trees guys, go away. That will delete all the trees. It doesn't matter what state they're in. They'll just disappear. That means that I have 0 trees, so it sets that simulation property to 0. I have 0 burn trees, so it sets that to 0 as well. And then it tells every background cell by broadcasting to all the background cells, hey, create a forest. And that means with some percentage chance, go ahead and build this. All right, one last thing that I want you to see is all the simulation properties. And you see that we have the burnt trees, the number of trees, and also we have here the desired density, which is 50%. That's actually pretty high. Let's change it to 30 just so that we can see what happens. Okay. Now the other thing that I want to do is I want to make a little plot here, and actually not desired density. What I wanted to plot was the percentage of burnt trees. So let me get that. Yes, we want to plot that. And somewhere between 0 and 100, that is very reasonable. Okay. Here's our plot. Right now it's setting at 60 because that's just the initial value. But we'll leave it there. Okay, let's restart the tree. We do that by clicking on this guy with the pointed finger, and boom, we created a new forest. Notice it's not quite as dense as it was before. That's because we changed that property. And now let's start a fire. Again, the same property, and we'll do it. Let's do it right here. Let's see what happens. And that's the end of it. That's because the fire couldn't jump. Okay, it's pretty isolated, not a lot of trees. Notice what happened here in the simulation. There's just not a lot of trees that are currently burning. Now let's see what we can do. It's growing. It didn't quite get anywhere. Keep trying this. Okay, and anyway, that's all there is to see. So, so bottom line, this gives you a feel for how simulations go. This lets you understand why we have this plot function, which is actually pretty useful in the simulation context. And your students might be interested in building simulations that either have a personal or scientific meaning. I'll see you all next week. Have fun.